All right, so we've been looking at the band logic. Remember, it's a modal logic of belief. Let's see an example of how it's used. In particular, we're going to take a look at the Needham-Schroeder protocol. And let me caution you that I'm not going to go through this in a great deal of detail because there is a lot of detail on these slides, but I recommend that you take a look at them after the fact. Okay, so what do? Well, we start with the protocol, and here at the top of the slide is the Needham-Schroeder protocol, which we've looked at a number of times, and you can see it's those 5 steps. Well, the first thing that we have to do is idealize the protocol. And remember what that is taking a look at each step in the protocol and figuring out what that step is trying to say in terms of beliefs. So for example, look at step 2. S sends to A message which has a new session key and that session key packaged up to send on to B. Well, the idealization of that is, some of the same message fragments and also these new belief statements. So for example, we've got the nonce that A generated. We've got a statement that says A and B now should share this new key KAB, that fact is fresh, and that same fact packaged up so it can be sent on to B, right? So once again, let me emphasize that to carry out this idealization step, you have to pretty well understand what the protocol is attempting to accomplish in each step. But if you take that at face value, we're going to use that to generate some beliefs that we can reason about, but also there's a set of initial beliefs that are about the context in which the protocol is operating. So here they are on this slide. So for example, A and S share a key, KAS. B and S share a key, KBS. S believes that at the end of the day, A and B are going to share this new key, KAB. A believes that S is an authority on keys that it might share with B. B believes that. A believes that that fact is fresh to this run of the protocol. The nonces are fresh. S believes that the fact that it generated a new key for KAB is fresh. And finally, here's a sort of odd one. B believes that any key that it receives during this protocol is going to be a fresh key. It turns out when you do the proof of this protocol using band, you need that last fact. And that fact was somewhat surprising to the people who originally did this. They said, that's not one that would have occurred to us. In fact, one of the great benefits of doing this sort of logical formalization is that it forces you to write down your assumptions, and it shows exactly how those assumptions are used in carrying out the proof. And if you have surprising assumptions there, that should be a piece of insight for you. Okay, so what do you do in any logic or in any proof? Well, you start with a set of assumptions, which we showed on the previous slide, and then you try to reason from those based on the inference rules to new pieces of information. And in particular, hopefully you'll get to the specification or the things that you want the protocol to accomplish. So for example, we saw step 2 of our idealized protocol, and we have this nonce verification rule that says, if a message is fresh and I believe that it came from S, then I believe that S believes that message. And so from that and the nonce verification rule and some of the things on the previous slide, we can derive that that A believes that S believes that A and B are going to share this new key, right? And then continuing with this, we have a jurisdictional rule that says, if A believes that S is an authority on things of type key, and A believes that S believes something, which is something we just proved on the previous slide, then A is entitled to believe it. So from that we can infer that A believes that A and B share this key, KAB, and also that fact is fresh. Again, I invite you to carry out that proof yourself and validate that claim. And then finally, finally, we carry on this through a number of steps, and we get down to a set of things that we're able to infer, and in particular, that A believes that it shares this key KAB with B, B believes that, and each of them believes that the other believes that. And it turns out that that's what we really wanted. I mean, that's our specification for the correctness of our protocol. And so this illustrates the method by which one might go about trying to prove a protocol like this, as complicated as it is. Okay, so what have we said? Well, we've said if you use a logic like BAN, and there are a number of others out there as well, that you attempt to formalize this domain of protocols and how they execute. And the idea here is to derive certain beliefs that give you the specification of the protocol. So for example, in this case, that A and B share this key and they both believe that the other has it and that they can use it. Requiring a logic like BAN is not a simple, using a logic like BAN is not a simple thing and requires a lot of insight into the protocol and also a lot of practice in using the logic effectively. And good luck with that. Thank you.